Ladies and gentlemen, we would now like to invite the third panel discussions with our speakers who will provide you with more information about opportunities and challenges of large-scale, land-based and floating solar in Malaysia. Please welcome the moderator for this panel, Technologies Tan Pi Hua, Principal Solar Consultant from AFRI. I would now also like to invite Dato' Charil Nazri Ahmad, Chief Operating Officer of Gentayu Sustainables Berhad, Sam Hong, Senior Manager, Business Development Senior Manager, EDPR APAC, Yuli Gotambot, CEO of Shizan Malaysia, KK Kong, Manager Director of Macro Engineering, Bernard Simon, Head of Solar Project Development, Baiwa, Muhammad Rizal Azmi, Industry, Power and Utilities Market Leader, Bureau Veritas Group. Please join us on stage. Thank you. Can you follow the sequence according to the screen? Thank you.
Hello. Okay. Okay. Good morning to everyone. Okay. Malaysia's Economy Ministry is already announced the National Energy Transition Program and targeted 70% of the renewable energy, and 58% is for solar. Okay, now the question is, Dato', what is the expected utility scale solar for ground mounted and floating solar capacity in Malaysia market? And since this policy is not ready, and what is your company view on this NETR program? Yeah, please.
Good afternoon and Assalamualaikum warahmatullahi wabarakatuh. My name is Khairil. I'm actually from Gentayu Sustainables Berhad. If you look at these panel members here, I think from Gentayu is because we are known to be a hydro developer, not so much a solar developer. Hence, if you look at the program book, our face is not there because we're not supposed to be here actually. But I guess because of how government is emphasizing as part of the NETR, the National Energy Transition Roadmap, on solar, though we are predominantly involved in hydro, we have to actually also look at solar because like what Mr. Moderator, Mr. Tan said earlier, 70% which is targeted for RE mix coming from renewable energy, 50% of that is actually solar. So I guess I think most of you, the participants here, you are all players in the renewable energy sector. And I'm sure you have actually gone through the NETR, the booklet, you've attended the session. So you know that there are certain key initiatives, right, that are predominantly renewable energy. And if you look at that, at those key initiatives, you can see that, there are solar parks, there are being introduced into the foray. There are also the hybrid hydro-solar floating program. And this, if you look at the whatever announcement that we've seen in the news so far, in the forum, in the launch of NETR, we can see that these two are supposed to be supported or pushed or being essentially managed by TNB. So you've got 500 megawatt that is announced for the for the solar park, and that is TNB to be the lead agency to push for the implementation. Though with the involvement of the state state economic development corporation and also some SMEs. And then with the floating, and we know that they are trying to utilize whatever reservoir for their big hydro to coexist in that particular environment. And these two are pretty much pushed or managed by TNB. And then for private players like I think most of us here, we are essentially looking at a few other initiatives that have been introduced in NETR, but like what Mr. Moderator said, certain policies are not there yet, but certain policies are already in place. Example of the policies that are in place is anything related to corporate engagement via the corporate power purchase agreement. We've been introduced with a program called CGPP. I think all of you know about that. NEDA market has been in existence for quite some time now, so some solar players have already participated by implementing, by having large-scale solar to participate in NEDA market. And then we have, I think this year people are excited with the potential announcement of TPA. I think this has been talked about many years ago already, ever since MESI 2.0 was actually introduced. So you have a TPA which can actually open up access to the grid and a different method or model for CGPP can be introduced or will be introduced. We heard about the government push in terms of extending the capacity for self-consumption for rooftop. That might not be within the purview of large-scale solar or utility-scale solar yet, because even though the policy was in place or is in place for any industrial consumers that are connected to 132 kV, but then it's pretty much limited to a cell which is utilizing the solar, utilizing the rooftop. So hence, even though we know some have been successful in actually doing a ground-mounted for this kind of connectivity, but that is not really in the policy, so it's what you call this, case-by-case basis. But opportunity is there for large-scale solar to be connected directly into the building via Celco. And then moving on from that, I think a lot of announcement has been made with regards to export to Singapore especially, and a lot of players, I think here as well, are already looking at it. I think my friends will be talking about the energy export a lot more in due course. But there's also an opportunity for large-scale solar opportunity. Green hydrogen, which is part and parcel of NETR, which is our new fuel, sort of. So to produce green hydrogen, you need renewable energy, and part and parcel of that is definitely large-scale solar. Obviously, with TNB having that 2,500 megawatt capacity that they are planning to integrate with their hydro, so that gives another element to perhaps pushing for electricity for green hydrogen production. And then I think there's also a push in the rail sector, whereby some players are going to push for renewable energy, again, solar, to be introduced in the real sector. So those are, I think, opportunities with regards to large-scale solar, utility-scale solar in Malaysia, based on NETR. Thank you.
Okay, thank you, Dr. Carriel. Just now, Dr. Carriel has also mentioned about the export energy. Yeah, Dr. Yuri, I would like to ask you one question. The Malaysia government always encourage the project developers to put up the solar, and export to the energy. It's just recently. Okay, what is the technical challenge and what is kind of the mitigation? Because TMB's transmission line to the Singapore, there is a limit. So what is the challenge from your experience in past project or maybe in Japan's, please?
Thank you for the question. My name is Uli from Shizen Energy. We are a Japanese company. We are in Malaysia since 2019. LSS3 is when we started here. Maybe I start with context of Japan. Maybe some people are not aware, but Japan is divided in a 50 hertz grid and a 60 hertz grid and is not connected to mainland like Korea or anything. And many islands in Japan are actually still run on diesel. So connecting just Japan itself on one grid is an ongoing challenge over there. So I think Japan is not a good example for connecting, because even the country is divided into two different frequencies. And that's why during the nuclear disaster, when the nuclear power plant shut down, they could not move electricity to that extent from the west to the east. But now, since the topic is very big on Asian supergrid, there are many discussions, the discussion from Australia all the way to Singapore. So from our perspective, there are definitely more advantages interconnecting grids than disadvantages. And especially for solar or for wind energy, maybe not so much hydro because you can provide base load, but for solar and wind, having interconnected grids is quite useful. And just taking Japan and Korea, the correlation is actually not that big. You could actually transport wind energy from Japan to Korea and back. That would be very beneficial. And it's not just that, it's also any kind of power producing, coal, gas, whatever, it opens new trading opportunities if you connect whole Asia together. And Malaysia having two parts, peninsula and here mainland, and you're already connected to Singapore, which is a big consumer, obviously, and they don't have space to install solar or other renewable producers. Plus, they have the international exposure where they need green energy. I think it's a great opportunity for Malaysia. So, of course, there are physical interconnections to Singapore and also on the other borders. It's just a matter of upgrading them. And you're in the same frequency. You don't have the challenge of Japan. So that's great. In terms of regulation, we understand the regulation in Malaysia is not here yet. But CGPP was also new to Malaysia. And we feel like you start with something and you kind of fix it on the way. From our perspective, we are okay with that. I think for a Japanese company, we are taking some risks of going into countries, into schemes where it's not all 100% clear yet, but we are confident that it will be cleared up. I think for the CGPP, there are still a few things that need to be cleared up. And maybe for the second round, as you said, maybe it will improve a bit. So we feel that the energy export from Malaysia to other countries is a great opportunity, mainly because we see the ecosystem is already here. I mean, many of the players are here today, well-established EPC companies and IPPs, developers, and so on. So fostering that, Malaysian know-how on renewables so that you can also venture into other countries, I think is a great opportunity. So from a technical perspective, it's all about maybe, privatizing some of these connectors or so, not just staying on the land between Singapore and Malaysia, but also going maybe offshore. There's a discussion about Vietnam. There's a discussion about connecting to Sarawak, Sabah. Indonesia is under discussion. All the technologies are there. Of course, Japan is very happy about this because they produce a lot of the subsea cables. So we would be happy to be part of that as well. So technology-wise, we don't see the issue. And we also look at it a bit on in a perspective of offshore wind. It's not so much a topic for Malaysia. However, if you start importing from Vietnam, which has a big plan for offshore wind, you can actually connect offshore with the interconnector technology from the UK and connect directly to Malaysia. And that's actually a technology we are trying to use in Japan, where we are developing offshore wind farms which are connecting islands which are still diesel powered to the main grid. So from our perspective, there are many advantages being connected, and the technology is ready to be deployed. And I think from a financing perspective, that there shouldn't be too many hurdles as well. Thank you.
Okay, thanks, Dr. Yuli. Thanks for sharing your experience in Japan. It's great to hear. Okay, in this Malaysia NFTR, BSS is also part of the topics, you know. So okay, so for Bernard, what is the a challenge of the BSS? Is this the right time to put up the BSS now, or probably you need to delay a little bit? What from your view, because you are from BayWa, German, right? So I believe you have this kind of internal discussion. Could you share with us about this thing?
Good morning, good afternoon, everyone. So I'm Bernard from BayWa. In terms of BS, I think we have to take a step back in terms of how BSS came into the market. If you look at LSS3, there was an introduction, LSS4, LSS3, there was already an introduction there in the tender process. But there was no so-called compensation tagged to it. And then in the most recent CGPP, there is also the BSS, but I think maybe 95% of the bidders or the winners, I don't think they actually put a BSS system there. And if they did, it's not, I wouldn't say, it may not be suitable for currently what is this, but I think you have to look at on the policy side. I mean, I hate to be a broken record. Everyone's talking about policy, right? There are many different types of BSS in the market. There's like the arbitrage, you load shifting type. In terms of grid stability, you have the spinning reserve type and you have the peaking type. So, and all this have different compensation models in there. You look to Japan, they are actually coming up with a type of BSS system market where there's a tag payment to it. So this is not say new to the IPP model, because our renewable energy is based on energy payments, right? But if you have something like a capacity payment, and that capacity payment is actually tagged to the availability of it, and you being available at a certain time where you need either grid stability or grid to circumvent the peakers coming online, because those are the ones where it's the most expensive, 12 to 2 and around maybe the end of the day, those open cycle gas turbines coming in. So if they can manage a sort of a type of compensation and have clear guidelines on what type of BSS is going to come online or needs to be tagged along from a renewable standpoint, because solar is a variable renewable. So, it fluctuates throughout the day. So you can have it as a peak shaving, you can have it as a grid stabilizing frequency response type. It will really make a difference. And also it gives the private side some avenue to actually charge and have a cost on that type of BSS system. So, yeah.
Thank you to Mr. Bernard. This is it's a very useful topic, for BSS, especially integrate with the solar. And also now the market also talking about the BSS integrate with the solar and the hydro. So, Mr. Rizal, so I would like to ask you one question. In Malaysia, there's many water dam and the hydro dam, and also the unused lake which is not connected to the river. And unused lakes is our most welcome by the government agency. But the fresh water and the hydro dams take a very long time for government agency for approval. Why this one will take longer time, and what is the challenge from the environmental control? Please.
Okay, thanks very much, Tan, for the question. Good afternoon, everyone. I'm Rizal from Bureau Veritas Group. We are a French-based company established since 1828. To respond to your question, I think we have to first make it clear that currently there's no specific policy guideline or even legislation focusing on floating PV systems. And if we're talking about environmental concerns, then definitely it has to be covered by the EIA, or Environmental Impact Assessment. When we look at the different types of water bodies, so each of them has, I guess, different sets of challenges when it comes to the environment. For example, number one, if we talk about drinking water dams, then I guess not just in Malaysia, but also in a lot of other countries, drinking water dams are considered as national security assets or sites. So any types of applications or permits or license for these types of water bodies are very restrictive, or I think in most cases entirely restricted at all. And probably the main reason for that is the potential of leaching of substances or heavy metals into the water, and thereby possibly contaminating the water supply, because of course it's consumed by the general public, including us. So, but if you can take a cue from Netherlands, for example, because in Netherlands, I believe about 20% of the land area is actually covered by water bodies. So they have quite an extensive plan to deploy floating PV systems over there. So they have conducted a few studies when it comes to this water quality standards. I believe they used sensors, underwater drones, to find out the composition of the water before and after installation of floating PV. And if I recall correctly, most of the studies indicate that there is little impact to the water quality, meaning that it still adheres to the standards required by the country. And I guess the next point, if we're talking about natural lakes, then it poses a different concern, which is mostly on biodiversity. The jury is still out because different studies point to different results. For example, when we talk about putting a floating PV system on the lake itself, then you are actually covering a certain portion of it for sunlight from entering the water. So this introduces a state called hypoxia, or lack of oxygen, which could lead to an increased amount of phosphorus, which then leads to an increase in the amount of algae, or what is known as algae bloom. So this will introduce toxicity also to the environment. But there are also studies which indicate that it actually helps reduce the algae. So that there's different results based on different studies. So I guess it depends on the situation, the location, on a case-by-case basis. And I think for hydropower dams, it's also a similar issue with phosphorus, because when you dam up the river, it already creates a potential increase in phosphorus already. So it could also lead to the same issue. But I guess the state utilities have already, Sarawak Energy has already tendered the 50 megawatt Batang Ai, and TNB also has their HHFS 2.5 gigawatt plan upcoming. So I'm certain there's already studies being done in this respect. So I think just to conclude, because I guess everyone's also waiting for lunch, I think there's more engagement should be done with the authorities involved in all these water bodies. For example, Department of Irrigation and Drainage, Department of Environment, as well as probably SPAN, Suruhanjaya Perkhidmatan Air Negara, so that everyone can be involved and understand the perspective of all parties to ensure that there's more involvement of floating PVs in the market. Thank you.
Thanks to Mr. Rizal. I think floating solar is very crucial for the environmentals. Okay, thanks. Okay, Mr. Sam. I know your companies have experience in the fresh water and the sea waters floating solar, right? Could you share with us your experience in this sea-based and on the freshwater base? What is the technical challenge between these two freshwater and the sea-based, please?
Thanks, Pihua. Hi guys, I'm Sam. I'm from ADP Renewables. We are a global RE asset developers with currently a 14.3 gigawatt of portfolio, ranging from various RE technologies such as solar, wind, energy storage, and hydrogen. So our group, we have set a commitment. We have committed to a goal of achieving carbon neutrality by as early as 2030. So I think for the rest of this decade, it's gonna be very interesting to us. So to address the question raised by Piwa earlier, I think, yes, at EDPR, we have executed an offshore floating solar PV system located in the Straits of Johor of Singapore. It's a 5 megawatt peak system. I think based on our experience there, I think some of the common challenges for a floating PV would be maybe on the unpredictable nature of the environment, whether it's the strong current, strong wave, and strong wind, which is especially magnified when it comes to a floating PV deployment. So that's why all this consideration, including the geotechnical condition of the site, we have to consider them before we deployed the floating PV, making sure all these components are taken into consideration when we design the mooring and also anchoring system. So apart from that also, I think maybe Rizal has highlighted earlier on the water quality. That one is also one of the challenge faced in offshore floating PV particularly, because offshore means we cannot really control the water quality. That's why I think seawater, that property of it, together with the humid environment, these are actually factors that increase the likelihood of corrosion. So in this aspect, it's essential for us to select the appropriate equipment. So coming back to this project that I mentioned earlier, we actually deployed double glass and frameless module exactly for that reason, so that we can avoid corrosion. So maybe another reason or another factors to be considered will be on the marine growth, which oftentimes seems to be a minor thing, right? Or in fact, it's actually good because when there is marine growth, it means that we are not disturbing the ecosystem too much. But this marine growth, right, because they do possess like additional weight to the floating structure, so it is important for us to control it. That's why number one is that during the design phase, we have to consider all this additional load. Also, during operation stage, frequent cleaning is required. So these are some of the factors. Otherwise, maybe some of the other challenges in terms of floating PV deployment would be, water body tends to be located rather remotely. And I guess when it comes to deployment of utility scale project, the interconnection distance, that one actually adds up to quite a lot of the capex. So due to the remote location, the interconnection distance might not be the shortest. And in fact, also because of a remote location, right, sometimes we do face challenges whereby the load, the consumption in that region is a bit too low. Hence, we cannot really maximize the potential capacity. But of course, that's why I think currently, whenever we speak about floating solar, there's always an idea of integrating it with an existing hydropower dam, because that will means we can actually tap into the existing substation, utilize it so that we can actually manage the cost wisely. So yeah.
Okay, thank you, Sam. Looks like the marine engineer is a challenge. I also have one project floating solar. We're also facing the very high challenge, especially when you have a strong wind blow. Your floater is moving around. So the marine's engineering knowledge, right, is a very critical and also very important to the floating solar. Okay, thank you to Sam. Okay, Mr. Kiki Kong. As you know, the floating solar will give a more energy, improve the PR and the solar tracker itself. also improve the energy. If they say these two combined together, they say like floating solar tracker, would it happen? Besides, you just ignore the commercial part. Would, in terms of the technical, can we make it happen or not in Malaysia? Please.
Hi everyone, good afternoon. My name is Kong. I'm from Mako Engineering. We are EPC and solar developer. Thank you, moderator, for the engineering questions. As usual, engineers like to think of a different possibility where the worlds, become better, right? So for this, probably this is in early stage of toying around the idea of tracker on floating platform. So I've seen some studies about this. Probably it's still in R&D stage. And in terms of practicality, I myself has involved in the 10 mega design of solar projects, floating solar. So probably I'd like to take this ahead, as in the O&M part of the consideration. From day one when you design, we as engineers should think of how to make the O&M, operation maintenance, convenient and easy, because this kind of asset is need to last design for at least 21 years in Malaysia, some countries 25 years, right, for the PPA contract. So, and this solar floating ideas and projects has been around for the past 7-8 years in some of the advanced country, and Malaysia also 3-4 years. So we are seeing a lot of failure of equipments, and the maintenance cost is getting higher. So the platoon floater, there are two types of floating. One school of thought is using the platoon floating HDPE methods, claim that UV resistance. But for your information, I'm seeing more and more failure on these products. Take note of that when you select your products, okay? This is very critical. It gives a lot of impact. So on your own O&M, okay? The other school of thought is using membrane, okay? Membrane and really flatten it on onshore, near shore, okay? We term it near shore, near the shore, so that is still within a lagoon area kind of implementations. That is another growth in terms of market segment for floating solar. So, and most importantly is when at the design stage you have enough data for you to decide on your anchoring, mooring kind of design, okay? If you have limited data of your water level, then that will be very, very challenging when you operate and run the projects, okay? So probably these are the few key takeaway, and take note of the nature, wildlife. You'll be surprised that you see lizard, big lizard, camping in the platoon on top of your solar panels. Your solar panels is full of bird shit, So those are the things that experience really count. Okay, and by the way, we have not solved that problem yet. the bird shit. Okay, we have used so many methods, sound and all sorts of things. They still come back. Okay, so there are some practical issues that really the industry need to take note of, and let's work together, and so that we can have more RE on this kind of, because land is a scarcity, okay? So if we can use the water, coexist of our renewable energy with assisting nature and also economic activities, that would be the best ideal approach. Thank you very much.
Okay, maybe I can add a few points. Actually, pontoon, right? In Malaysia, actually, we also have a concrete pontoon. So for those, if let's say you want to put like inverter station, transformer, if let's say you have a large-scale floating solar farm, right? 100 megawatt, 200 megawatt. Yeah, so concrete pontoon is one of the solution, you know, for to put up the transformer station or inverter station. Then it might be also put up this solar tracker, because why I see that in global, like what Mr. KK Kong mentioned, a lot of people starting study about this solutions, you know, because you have better PR, then at the same time tracker give you some more energy. Although the tracker, the PR in ground base is your PR probably is not so good, but in the water base, you know, probably you can improve your PR. So with they say like your tracker improves 15%, and at the hydro, some these are water floating solar, improve again another 6 or 8%. Is total up, right? Is probably around 20 somethings. You know, the number is look like it's very great. Of course, a lot of engineering study need to be I'll say take the environmental account, as what Mr. Rizal mentioned. You know, we need to consider about the water quality, you know, and also the environmental, especially this hydrogen sulfide. I think Dr. Carey also know hydrodam normally have this hydrogen sulfide issues, you know, and the salt issues. I think Sam also mentioned that salt also one of the key issues, you know. So I hope in the future this thing can be sought out and help the country to generate more energy and export to the others country and the better currencies. Okay, thank you.